In this video, we will discuss sections 3.13 through 3.16. Until this point, in order to consider multiple cases, we have relied on multi-way if-else statements. While they certainly work, overuse of nested if-else statements can make a program difficult to read. Consider the nested if-else statement in listing 3.5. Based on the value of the single variable status, we determine which block of code will be executed. When we have a single variable or expression that determines which block of code out of multiple blocks will be executed, we have a much cleaner way to code this, the switch statement. We now introduce the switch statement to replace the nested if statement and improve readability. A switch statement executes statements based on the value of a variable or an expression. The switch statement greatly simplifies coding for multiple conditions. The flowchart for the switch statement is depicted here. The switch statement checks each case one at a time, starting at the first case, and executes the statements in the block of code corresponding to the case that first matches. Let's look at the syntax of the switch statement. The keyword switch followed by a space and a pair of parentheses and a pair of curly braces. In the parentheses, we include the switch expression, which can be a variable or an expression that evaluates to a character, integer, or string type. The switch expression cannot evaluate to a Boolean value or a double. Inside the curly braces, we list all the possible cases using the keyword case, followed by a corresponding value that matches the data type of the switch expression, followed by a colon. The computer will consider the cases one by one from the first case, looking for a match to the value of the switch expression. When a match is found, the statements starting from this case are executed until either a break statement is encountered or the end of the switch statement is reached. The default case is an optional case that is used to perform actions when none of the other cases match the switch expression. The keyword break is optional and immediately ends the switch statement. While the break statement is optional, it's important to note that forgetting a break statement will cause Java to continue executing statements in preceding cases. We must be careful to only exclude break statements intentionally and with good reason. Consider the switch statement in the example shown. We will use the variable day as our switch expression. Day is of the data type integer and can contain the value 0s through 6, which represent the days of the week, where 0 is Sunday, 1 is Monday, and so on. We are to write a statement to print out weekday if the day is Monday through Friday, that is 1 to 5 respectively, or print out weekend if day is 0 or 6. While it is possible to achieve this with a nested multi-way if-else statement, the switch statement provides a much cleaner solution. In this example, the variable day has already been declared and given a value before entering the switch statement. We never declare and initialize a variable in the switch expression. The value of date determines which case will be executed. Notice that there is only one break statement in the switch statement, in case 5. Let's look at why this might be not only correct, but actually preferred. So let's suppose that day has a value of 3. Upon entering the switch statement, case 3 is executed, but there's no break statement. Therefore, we fall through to case 4, which also has no break statement. So again, we fall through to case 5. We execute the code in case 5, and because of the break statement, we end the switch statement. This is known as fall through. If we did not use fall through in this switch statement, we would have to repeat the code in case 5 for each of the cases 1 through 4, and we would repeat the code in case 6 also in case 0. This would result in redundant code. Additionally, note that the cases do not appear in numerical order. That is, case 0 appears after case 5. This is because in order to utilize fall through to its maximum benefit, we've grouped the cases based on the resulting actions. Now let's trace the switch statement for day equals 2. When day equals 2, we begin evaluating at the first case. Since day does not equal 1, we continue evaluating to the next case. We find a match at case 2. Because there's no breakthrough in case 2, we fall through to case 3. We execute the code in case 3, and in absence of a break statement, we fall through to case 4. Likewise, when we execute case 4 and do not encounter a break statement, we fall through to case 5. We execute the statement in case 5 and print out weekday to the console. Next, we encounter the break statement. The break statement ends the switch statement, so we skip all remaining cases and execute the first line of code following the closing brace of the switch statement. Now let's consider the problem of printing out the Chinese zodiac sign for a given year and see how we can use a switch statement to solve this problem. Notice from the diagram that there are 12 Chinese zodiac signs, and given that the 1900 is the year of the rat, we can see that by computing year mod 12 and matching the result, which can only be an integer in the range 0 to 11, we can determine the zodiac sign for any given year. We can use the switch statement shown to solve this problem. Notice that we will use the expression year mod 12, which evaluates to an integer value in the range of 0 to 11, as our switch statement expression. It's worth repeating that we are not restricted to using only a variable as our switch expression. Our switch expression can be any expression that evaluates to a character, string, or integer type. For now, we will only use switch expressions that evaluate to integer type, that is int, byte, or short, since we haven't yet introduced the char or string types. Additionally, notice that the parentheses are required, much like in an if statement. And finally, notice that there is no semicolon following the parenthesis or the closing brace. In fact, it's worthwhile stating that in Java in general, we do not have a semicolon following a closing brace. When we want to evaluate an expression based on a condition that evaluates to a Boolean value that is true or false, we cannot use a switch statement, but we can, however, use a conditional expression. Consider the if-else statement on the slide. If x is greater than 0, y equals 1, else y equals -1. The value of the condition, x greater than 0, determines what value will be assigned to the variable y. It is important to note that we are assigning a different value to the same variable, y, based on the result of this conditional expression. This would not be applicable if we were assigning values to different variables. We're able to rewrite the if-else statement as an assignment statement using the conditional expression shown to determine the value that is to be assigned to y. A conditional expression is made up of 5 components. The first is a Boolean expression enclosed in parentheses. The next is the question mark. third is the expression after the question mark, which is to be evaluated and the result returned if the Boolean expression evaluates to true. The next component is the colon. And finally, the fifth component is the expression after the colon that is to be evaluated and the result returned if the Boolean expression has evaluated to false. Consider the two examples on this slide. First, we have an example of a conditional expression being used in a print line statement to determine what will be printed. Based on the result of the expression num mod 2 equivalent to 0, the print line statement will either display is even or is odd. Notice that the conditional expression is nested inside the print line statement. Therefore, the conditional expression is evaluated first, and based on the result, the print line statement is executed with the corresponding string. It is not the case that both is even and is odd will ever be printed out. Next, we have an example of assigning the larger of num1 and num2 to the variable max. Pause this video and take some time to identify the Boolean expression and rewrite the corresponding if-else statement. Realize that a conditional expression always corresponds to an if-else statement and not just an if statement. Can you explain why? As we move forward and develop more complex expressions, it is important that we review the concept of operator precedence. You may recall from algebra, PEDMAS, or please excuse my dear Aunt Sally, as an acronym for operator precedence. Parenthesis, exponents, multiplication and division, and finally addition and subtraction. This means that the expressions in parentheses are always evaluated first, beginning at the innermost parenthesis. When evaluating an expression, we evaluate left to right, evaluating exponents first, followed by multiplication and division, and finally addition and subtraction. Remember that all binary operators except the assignment operator are left associative. The assignment operator is right associative. That is to say that when we evaluate everything on the right of the assignment statement before evaluating the assignment operator and making the assignment. Now consider an example. We start evaluating with the inside parenthesis first. We notice that there are no exponents in the expression, so moving left to right, we look for multiplication and division. And we evaluate the first multiplication, followed by the next multiplication. Now we move left to right again, looking for subtraction and addition. We evaluate the addition, followed by the subtraction. And finally, we evaluate the relational operator greater than. It is very helpful to write out the trace of the evaluation in this expression with only a single evaluation on a line to ensure that you arrive at the correct result. We close this chapter with a brief discussion on debugging. Logic errors in a program are called bugs. Debugging is the process of finding and fixing errors in a program. Syntax errors are easy to find because our IDE, Eclipse, will indicate where they exist and give us hints as to what's wrong. Runtime errors aren't too difficult to find either because Java will give us hints as to what the problem is when the program aborts. Logic errors, however, can be very difficult to locate. When debugging a program, we introduced the concept of rubber duck debugging, and now we'll introduce a couple more techniques. The first technique is that of hand tracing the program, where we simply review the program line by line to determine where the error lies. Another is that we can insert print statements throughout the program that display the values of the variables at numerous points in the program, such as before and after all assignment statements. This will help us isolate the error. Finally, for larger, more complex programs, we can use the debugger that's integrated into our IDE. We will not cover the Eclipse debugger in this class, but the curious student should refer to the supplemental material in the online textbook for more information.